Hello everyone. Good morning. Good morning. It's good. Come on, wake up.
So hi everyone. So today we are going to talk about observability. So last talk was a kind of deja vu for me. Last 6 months I was doing the same thing that he mentioned. So now we are going to move a slightly bit advanced and talk about how to move from reactive to proactive approach in observability. So who are we? I am a cloud engineer, a CTO, a community builder, and a CNC, cloud native lead for New Delhi. And yeah.
Hey, so hi everyone. This is Abhinav. I am more of a Kubernetes head with a traveling soul. So I am working as a DevOps engineer at Deftron, and I also am the maintainer of Deftron open source project. I'm also CNCF ambassador, AWS community builder, organizer of CNCF New Delhi, and author and founder at DevOpsDiary.in, which is a platform where I'm trying to curate more resources on the CNCF ecosystem. You can check it out. And to connect with me on LinkedIn and Twitter, you can see my handles. Feel free to connect with me.
Okay, so observability is not just about monitoring. Any idea about what actually observability is? Okay, no. So this memes actually shows it perfectly that observability is not just about tools and monitoring, but it's way more than that. Traditionally, it was around three pillars: collecting matrices, collecting logs and traces, and going and manually checking into things. But later on, things changed, and now it's about a lot of things like user behavior. Like when you use Zomato app, they even track how many times you're switching screens between Swiggy and Zomato. So that's a kind of metrics they're collecting nowadays. Code level details that would also involve security, like in a DevSecOps pipeline, you do right from the shift left approach. So that also is now included to observability at different aspects like build times and everything. And the network mappings about how your packets are flowing and everything should be tracked into your traces. And what are the challenges when you set up observability nowadays? So if anyone has set up open telemetry and you leave everything by default, the amount of data that comes, that's way beyond you can think of. Like I have faced a scenario wherein my log billing was way beyond infrastructure billing. So that's what it can reach. So you need to be very careful around that. And tool integration is very difficult. Like if you move from, let's say, New Relic to Datadog, before open telemetry, there was no common ground to move between tools. So you had to rewrite, restructure everything if you wanted to change vendors or change tools. So you need to be mindful of that. Then there are security concerns. Let's say under tracing, how packets are flowing, and if you don't hash them properly, there could be, let's say, PII data in the logs, and someone could misuse it, or API tokens passing on. You need to be very mindful of that. Then you need to, of course, not only train your DevOps team or your cloud team into observability, but all your developers, because in the shift left approach, it begins at developers till the deployments happen. So you need to take care of that. Then alert fatigue, if you don't properly set it, alerts would keep coming in and your Slack would always be red, or whichever channel you use. So you need to be setting it very properly. Let's say you don't need to set up for crash loop. You don't need to put in multiple things. You just have the required amount of data, required amount of alerts, and use them. Then nowadays, people use a lot of managed services, self-hosted services, or their own hosted infrastructure. So complexities change depending on where you are hosting things. So based on that, you need to choose the right approach or the right tool and work on that. And then the main thing that we will be talking about the reactive mindset now.
Okay, listen to me very carefully. I know where you are hiding, and I will find you and I'll fix you. So that is the ultimate motto behind the reactive approach, right? The one that we are already using. Traditionally, the reactive approach has been coming up in the market, and we have been using for a long time. So in this reactive approach of observability, it's basically about addressing any challenges once they occur, right? Once the situations are being created, once you have faced certain issues, then you are dealing with those issues. One of the classic example would be addressing server downtime, and it can be in any way that is being reported, right? Maybe the end users are reporting you, or maybe some alert mechanism you are getting once the server is already being crashed. Now what? It is already being crashed, right? Another example would be performance issue when you are getting from your clients or your customers. They are reporting there are some latencies in your application, right? There are latencies in loading the application pages. Those are certain issues or common classic examples that you can see in reactive way of approach of observability. And one of the good thing about reactive is it's very cost effective since you don't have to deal with a lot of different things, and it's very easy to set up because it's just one kind of one-time thing, right? It's very easy to set up. You don't have to worry about any of the complexities in reactive approach of observability. Now again, shortcuts are not really good, right? You should not take shortcuts for rides for always. So there will be certain shortcomings, starting with delayed problem identification. You will get to know about the problem once problem is already being created, right? Once you already have faced certain things, then only you are getting notified about those problems. Second thing is eventually it will lead a negative impact on your customers because now your application is already down. It's already crashed, right? It will leave a bad user experience and will leave a negative impact on your customers. The next thing is operational inefficiencies, obviously. So in certain cases, in these cases, in your organization you already have developers, right, who are working on different projects. You have already given certain timelines, certain sprints, certain deadlines. Now you want your firefighters to come again here and deal with these current existing issues which you got notified just now with this particular approach. Limited root cause analysis because you won't be getting in-depth analysis of why exactly this problem statement occurred. You only know this is broken, I need to fix it, that's it. You won't get much detail about that. Scaling is a nightmare if you are dealing with this particular approach in a reactive way of observability. So when you think about scale, when you think about it at scale, right, you are having thousands of microservices which will churn tons of data, right? In that scenario, the reactive observability becomes really difficult to handle with. And obviously, as Ashish already mentioned about, right, it's prone to alert fatigue. You'll be getting tons of notifications on your Slack channels or let's say in your Discord, whichever you are using, and you are not sure which one is relevant for you. So in the previous slide as well, previous speaker talked about how to configure those alerts in an appropriate way. That is one of the most important thing which you won't be getting in reactive observability.
So now let's move on. Why do we need proactive observability? So everything that Abhinav right now mentioned, we need to fix that in some or the other way to improve our user experience, our developers experience and everything. So first thing that would help is even before the errors come up, let's say in case of metrics, even before you know that metrics are rising slowly, your proactive approach would tell you that your metrics are rising, so you should take appropriate action. And way more proactive method would be even have a solution set up for it. Let's say have a runbook running so that your HPA scales out or your new plugins get installed or whatever it should happen. That would help you increase your uptime and reliability. So a use case for this we will be discussing later on. Then of course your operational efficiency would happen, and when your developer or DevOps team get time, they would have more time for innovation and they can think of better ways of optimizing your application or adding new features and more things. Of course, when you have lower downtime, your user satisfaction is at maximum. So if you look at recent events, let's say in Zerodha or Upstocks, the downtime, and if you see the rage at Twitter or LinkedIn, a lot of people are angry about it. A lot of money loss is happening. So that should not happen. Your user satisfaction should be highest and it could help you in that. And of course, when you do all of your things, your money gets saved based on your customer money as well as your money on your infrastructure end. Then of course you would also gain a competitive edge because if you give your maximum uptime, most people would prefer your platform rather than other platform. Then what do you need for moving to proactive observability as a strategy? First, start with predictive analysis. This is the most basic one. Have a regression learning if you want to self-host and just put up a metrics graph and your basic ML would do based on both logs and matrices. Then have automated alerting systems. A lot of people don't know, but they're partially already on proactive methods because everyone has alerts right now. Previously, it did not used to. Before Alert Manager, there was no option. You would have to go and check things. Then have continuous monitoring in place. And yes, once you set up electric systems and once you are at a level, you should also set up automated incident responses. By what I mean, as I mentioned, use Rundex or have HPAs to fix impending issues that you think are very common one and it can be fixed automatically, where you don't need any manual interaction. Then always your basic matrices logs are done. You know how much my CPU utilization is happening, how much RAM utilization is happening, what is the network bandwidth. Now translate your business objectives into your measurable metrics. How many people are logged into your app? What is the screen time they are doing? Use those matrices, work on them and convert them into measurable metrics in such a way that you can attract more customers, hold them for longer and earn more money. And then of course, foster the culture of observability across left to right, start from developing till your deployment. And so this is a long list. So if you are planning to move to it, I would suggest take a photo of this. So your first column shows about how you ingest your data and how you store them, starting from logs, matrices, traces, the three pillars of observability. Then your automation, how automation would help you in your anomaly detection, predictive analysis. These are paid versions, but there are open source versions of them as well. And then last is the add-on things, when you could put on alerting and notification, run automatic run decks, and self-healing systems like Chaos Monkey.
Perfect. So we have talked about the tools and technologies and what exactly is proactive observability, right? Now, in the last session also we talked about optimizations, optimizing alerts, optimizing observability. Now again, optimizing observability we are talking about. Cool. So the very first thing is, and one of the most basic thing is having a shift left approach. In shift left approach, be it you're talking about in terms of security as well, right? Or in terms of observability, it's something which should be implemented from the scratch. You should not be worried about it once the things are already escalated, right? Having the initial base, in the base setup itself, you are talking about or fixing those things which will not, which will prevent you getting errors or let's say any of the issues future in production. The very first thing is integrating observability into your development environments. Now, how do we integrate observability in development, right? So I will quickly show you a graph and I will try to explain this graph. So it's one of the it's one of the things that we have implemented at DevTron. So for, if you see here, orchestrator API latency, right? Again, whenever you're creating any application, then APIs will be there for sure, right? You'll be building APIs. When you're dealing with APIs, these are the dungeons of your cloud environment or application environments. If taking the request and giving the output, right? So it acts as a dunzo for your applications basically. So if you see here, these are different API calls, the graphs that you can see here, and what we are measuring here is we are measuring the latency of API calls. It will help us identify which APIs are taking longer time in response, right? To respond basically. And it will give us the data so that we can optimize certain APIs, those specific APIs which are taking longer time for response. And it will help us to improve the user experience of the customers, right? This is something which you can integrate within your applications, and OpenTelemetry can be one of the great way to integrate within your applications. The next thing is training teams for proactivity. Just by introducing tools or having those things in the place won't help you, right? Your team should be efficient enough to build the customized dashboards. They should be aware what is the customer need, and they should be known of how exactly you can build those dashboards so that you can observe and monitor those particular customer dashboards as well, right? And for that you should need your team which is efficient enough to build dashboards. They should have proper training, they should have proper resources so that they can do it on their own. And for that, what we did was, we did an entire CI/CD monitoring platform. So if anyone is not aware of DevTron, DevTron is an open source application management platform for Kubernetes specifically, and we do almost everything in Kubernetes, the CI/CD or monitoring or observability, anything that you need for a Kubernetes, that DevTron should be able to do it. So for the CI/CD specific part, right, if you see here, the graph that you can see here, right, the CI/CD comparison graph, all the CI triggered. So this is the data of one of our environment wherein what we are capturing is the comparison between the time taken to trigger a CI to its deployment, right? Thereafter, the number of CIs has been triggered, the number of CDs has been triggered, and this will help us to understand if the particular resource or the number of resources that we have given for this DevTron instance for that particular client is enough or not. That will help us internally to train. That will help us internally to judge if this particular system is enough to give the response of this number of triggers or those bulk CD triggers basically. And again, in reckoning, we have built the automated dashboards as well, which will give you the live count of the CI builds, CD builds. These are some custom things that needs to be done from our end. And since we are efficient enough to build this can be incorporated on your organizations as well. So as you go along with this approach, with the proactive approach, you can build certain custom dashboard to monitor and observe your application status and whatever the fields which are important for you. The next thing is establishing proactive protocols. Again, it's one of the most important things. So we are done with the API latencies, we are done with the custom dashboards, which can help us monitor and observe the client's requirements and the performance of the dashboard, right? But we also need certain protocols so that we make sure that if there are any cases even after that, then it should auto heal or we get notified about that. The first thing that you see here, it's a Slack alert which shows some RDS free available memory, right? It gets automated resolved. So Again, one of the alert I can show here is a Discord alert. So you can customize and you can set up almost anything, be it on your Discord, on your Slack, or whichever medium you are using for getting the alerts. It needs to be configured. The point is, it needs to be there, right? So that you get notified if there are any unusual activities. If you see here in the Discord alert as well, right, there was some cube job failing, and after a certain time, certain interval of time, it automatically got resolved. So these things should be there in place so that you ensure that you are into the proactive approach and you are dealing with the observability in a better way. Now, if I talk about a use case here, so let me talk about one of the case studies that we faced around a year ago, and which eventually resulted us to create the entire orchestrated API latency graph. So, there was a use case around a year ago. We got notified from one of our customers wherein the DevTool dashboard was taking longer time in loading the pages. Right, some of the pages were failed, some of the pages were not loading, and these were caused because of the latencies in API calls. And that was one of the classic example that I showed below before, right? That's why we built that particular entire graph. We integrated open telemetry within the system so that we can get the requests for almost each API calls that is being happening for each pages that we have. Almost for anything, be it your CI trigger, application details, Kubernetes deployment, CD triggers, observability, anything. For almost every page, we integrate that API latencies, and now we are getting the alerts if there are any API calls that are taking longer time than the user time that we defined. Then we automatically get notified, and we can work on optimizing those API requests. So this is one of the case study that we faced a year ago, and we fixed it. And this is just one of the cases that I have faced personally, but there are classic examples of proactive monitoring worldwide, and a lot of different case studies are already being public in the internet.
So BMW is one of the bigger names everyone knows. They use observability right from pre-sales till the car is sold. So if you don't want to get stuck on road, they help you out. Similarly, G helps you not dying out of a plane crash. So they track everything right from customer data, how many people boarded and everything. If you check, it happens, including your black box data. It includes fuel consumption and everything. They correlate that data. They have their own models. Check out, run system tests on every engine after every flight, and they make sure that this flight is ready to roll up. Similarly, BMW sends notifications to its users for their connected car so that you don't screw up in middle of the road and are happy to go anywhere. And probably Netflix is one of the very common names. So they use, a lot of companies use Chaos Monkey for chaos testing, but they have automated it in a very specialized way. Chaos Monkey is not only on the basis about how they have configured it. It automatically reconfigures after a while and keeps testing their staging environment so that they have their best uptime on the production, so that they can fix those issues from staging into production. And they, if you would see in the 5-year past, they wouldn't have gone down even for a while if you look at the news.
True. So that was pretty much about the entire session, proactive approach. If you remember, right, initially we asked observability is not just about monitoring and what it is. So anyone would like to answer to that question now? Anyone here? We got pretty much time. We got around 10 minutes still. So if anyone would like to speak up, cool. So observability is not just having graphs, right? When we say observability or monitoring, the first picture that come into the mind is having different graphs. Even I showed the graphs as well, right? But it's not just about the graphs. When you are dealing with the software development life cycle, right? Right from once your source code has been committed, right from you integrated your CI/CD systems with your version control, everything after that comes into the observability. And how you want to integrate that depends upon you, right? Let's say you are building a container image, right? Then there should be proper visibility of every phase that is being happening. Let's say if you have integrated pre-build stages, or let's say post-build stages. Before building a container image, for example, you want to run some SonarQube test cases for your static code analysis of your source code, right? That is again one phase in your CI/CD pipeline. You should be having clear visibility of that as well. Thereafter, once the build is being completed, let's say for instance you want to run some test cases before deploying your application into the staging environment, for instance. Or maybe if you are dealing with sequential deployments wherein you are promoting the same image into multiple different stages before it gets promoted to the production environment. Or let's say if you are dealing with parallel deployments wherein once you build your container image, and you want to simply deploy that container image to multiple different environments parallelly. Anyway, any pipeline that you are using, having the visibility is very important, and who deployed it, who built it, what are the vulnerabilities in that container images, and how or in which package those vulnerabilities can be fixed. So the entire end-to-end lifecycle, that's what Defton promotes as well. It's an open source tool, by the way. So that's what it comes into the entire CI/CD pipelines, all the visibility of every phase that you are dealing with, and some of the common cloud-native tools, for instance, Trivy, or let's say Argo CD, right, for the GitOps operations, Argo workflows for creating the workflows, Grafana for the dashboards. All tools are natively integrated within the platform, which can be used and leveraged as an internal development platform for the organizations. And it's 100% open source, so feel free to give it a try. And coming to the end of the session, so what we discussed was transitioning from a fix it when it's broken to prevent before it breaks. That's what proactive approach in a nutshell, right? With this particular approach, you get enhanced system reliability, improve user experience, of course, cost savings for sure, operational efficiencies that would be there for sure with the proactive approach as compared to reactive approach, because you already know because you already know things before it breaks, right? So you can plan accordingly and fix those things so that it will not break in future deployments or future releases of your applications. The next thing is adopting predictive analysis, automated alerting, continuous monitoring, and team training. Having your team trained for the specific tools that you are using for the entire monitoring system. That is again one of the conclusions of having a proactive approach of observability in the entire SDLC that you are using. And embracing observability early in the system, which we initially talked about, right? Having a shift left approach to the observability is also one of the important aspects of having proactive observability that we discussed about. Cool. So now, who are we? So product engineers or the SREs who are responsible for having 99.99% uptime, right? Now, how do you instrument your application? So when it comes to any organization having these requests, right? Eventually what happens? Eventually it's a low priority item because you have certain features that needs to be shipped to the clients. They have been asking for a long time. Now the status is pending state because it's not being prioritized in your sprint planning course. You might be planning to prioritize in the next call, but it never gets prioritized. That is the fact. And when things break down, the system comes into the maintenance stage, right? This is the reality that we are dealing with. Cool. So thank you so much for being so patient. You can scan our QR codes, connect with us LinkedIn. And the image that you see here, right? Almost everything here, all your data centers, all your API calls, all your networks, all your packets, everything is being monitored and observed. That's what proactive observability means actually. Feel free to shoot out questions if you have any. We have a couple of minutes left here.
So in the start, you mentioned in the reactive model that your Discord or Slack is getting. In the start, you mentioned in the reactive model that Discord or Slack is getting bombarded with notifications, right? But even in the proactive model, you did mention that you're still getting alerts. Exactly. So what's the difference between the alerts within your reactive versus your proactive approach?
The quality of alerts. It's about the quality of alerts that you are getting, right? If you have a large data, right, you'd be getting multiple numbers of alerts, right? And in the reactive approach, the alerts that you are getting, it's basically how you define your alerts that you want to be, right? In a reactive approach, okay. So in a proactive approach, you already define those things which you want. You are dealing with things which will not break, basically, right? You are trying to prevent things breaking into the production system. And if the things are, for instance, I will give a very small example. So let's say CPU throttling or memory throttling, right? So before actually your pod gets failed into, let's say, crash to backup state, before itself you are getting certain alerts. That is proactive alerts. That is proactive monitoring, right? Before getting things failed, you are already getting the alerts. That alerts are being referred in proactive approach. And Discord and Slack, these are just the mediums of getting alerts. It can be anything that you want to. You can have those mails, alert mails in your mail system as well. It can be anything.
And to add to that, you can improve the quality of alerts. First of all, reduce your logs, matrices, traces to minimal amount, save cost. And on that, of course, you do create a certain type of alerts, but if you have certain model places, you can automatically generate alerts as well. I mean the alert identifiers, not the alert itself, and use them instead of manually creating them, because sometimes what happens is you are getting rid of a system or you are adding a new system and you forget to add alerts or delete alerts, that would create either garbage alerts or no alerts, and you want that to be automated. So there is no such tool available, but we have internally built one for ourselves, and similarly you can do. It's pretty easy for that. Anyone else with any questions?
Okay, then I think we can wind up. So we will be here only. If you have any questions or if you want to connect with us, please feel free to connect with us. Thank you so much for being so patient.